will be dedicated to presentations of implementation of the projects on the study, on the pilot or experimental study for the possibility of transporting different mix of hydrogen and natural gas with different concentration on existing pipeline systems. This work was started by regional gas company under the brand of which there are 20 gas distribution operators of gas networks in Ukraine in our weekend, and with active participation of this company. It provided 5 test sites to study different aspects of transportation of the mixtures of natural gas and hydrogen through the systems of distribution. Before passing to realities, to the practical work, I would like to tell you on a very sad news. On the 29th of April this year, due to complications after a long-term illness connected with COVID, passed away one of the scientific managers of our scientific group, the Commission of the Academy of Sciences of Ukraine, of the Institute of Gas, Igor Nikolaevich Karpenka. So I ask 1 minute of silence to commemorate his memory. Dear colleagues, let us pass to our work. First, I would like to introduce myself. My name is Unigovskyi Leonid. I am the General Director of the consulting company Naftogazbudinformatika. Exactly this company was that the original gas company addressed to with the proposal to create a scientific group to scientifically support the project for studying the possibility to transport the mixture of hydrogen and natural gas on the systems of pipelines. The group was prepared in 2020, and now there are representatives of 4 academic institutes in this group: the Institute of Electric Welding, Institute of Gas, Institute of Coal Technologies, and Chemical and Mechanical Properties Institute by Karpenka. 2 high schools, Lviv Polytechnic University and the National Institute of Oil and Gas from Ivano-Frankivsk. Also, other representatives of the National University of Building and Architecture of Ukraine are joining this work. Also, representatives of state enterprise Ivano-Frankivsk Standard Metrology are participating in the group which currently is supporting this project. I want to tell you that obviously this group will increase, will become larger because more and more tasks are adding to its work. And we, the company Naftogazbudinformatika, have the task of overall coordination, supervision of works, and creation of a certain environment, so to allow for the experiments to be conducted rather quickly and efficiently. Not to distract more of your attention, I want to now dwell on certain technical issues and logistical issues of today's agenda. On the first webinar, we shall practically consider 2 issues, 2 matters. The first, analysis of tightness of the distribution gas pipelines in the experiments. And the second issue is this webinar is the first one from the series, but it will be continued in the second and third ones. On the second webinar, we plan to consider to review the issue of metrology, and on the third webinar, the problems connected with the influence of a gas hydrogen mixture onto the metal pipe. As regards to the technique, the agenda. We shall have three speakers today. The scientific consultant of our company, Naftogazbudinformatika, Mr. Kostogris. He will deliver on the program on the problems of tightness. Thereafter, a professor, head of department of gas, Soroka Boris, will have the floor. He is the head of the group in charge of hydrogen tests there. And then the doctor of technical sciences, also representative of the Institute of Gas, Pianych Konstantin, will take the floor. It is our core group of speakers for today. Also, at the end, we shall watch a little bit of video how the test site in Ivano-Frankivsk Oblast is being prepared for hydrogen tests, for fire tests. About the questions, we have a chat for the questions. You can put them into the chat. We shall try to answer them as much as the time will allow us for that. I promise you that on the website of Original Gas Company and on the website of Naftogazbudinformatika, we shall answer all the questions which will be put by the interested persons today. And let's now switch to the presentations. I will give the floor now to the driver, so to say, of our project, a person without whom this project eventually wouldn't be possible. I want to tell that even the meetings we organized once a week, now once every 2 weeks, they are also helping to promote this project quickly and efficiently. I want to give the floor to the director of the Department for Strategic Development of Regional Gas Company. I will repeat, the driver of our project, Mr. Stanislav Kazda. Mr. Kazda, you have the floor. Thank you, Leonid. Good morning, good afternoon, ladies and gentlemen. I don't want to take much of your time. I will tell in two words what we are doing and about the organization of our project. First question, why we started to test hydrogen transportation and how it influences on the distribution networks. The answer is very simple. We do understand that in Ukraine, in the gas distribution networks, the hydrogen and other gases, other type of gases will appear, will come to them soon or earlier. Ukraine has no other comprehensive testing programs. That is why in 2019 already we did our own experiments to do it. I mentioned we focus on the issues of distribution networks and the issues of final consumers. We have three main directions of testing. The testing of gas equipment in the sense of gas distribution points, the pipes. And the second direction is connected with metrology, meters, and diagnostic devices. And the third area, third direction, is dealing mainly with devices measuring and controlling the consumption at final users, consumers. Who is doing all that? We have a consortium of 20 DSOs, distribution systems operators who supply gas to many consumers. We cooperate with more than Ukrainian different institutes, scientific institutes, and their work is organized by Naftogazbudinformatika, the consulting company. And those institutes conduct those scientific works for us. How do we conduct the whole project, we planned 3 steps of the project. The first step was preparation of the project. This already finished last year. The second part of our project is covering up to the part of 2020. That is a test 2022 testing in the laboratories and test sites, and up to 2025 we shall check the results of this testing in the real conditions, in real life, on the real pipelines and networks. About test sites. Test site is a full-fledged comprehensive reflection, embodiment of the real network. All the parts of the test sites consist of the equipment and technologies that was really used in the distribution network. The equipment which was operated in the networks of natural gas transmission. Talking about the budget, we have a budget of about €1 million for these tests, which we need to conduct all the necessary experiments. We should see that we are moving along, I was mentioning, and they represent 17 different types of experiments, tests. And there are about 150 kind of tests for 17 types of experiments. Obviously, we should have a rather serious budget for all that. Why we decided to organize today's webinar, today's event. It is very important for us to share our experience, both with the colleagues in Ukraine and with the colleagues abroad. At the same time, we would like to obtain feedback and information, exchange of information from the specialists in other countries of Europe. So if anybody wants have more details about our project, we are ready to organize bilateral negotiations and connection and to exchange information we have on the results of our experiments. That's all from my side now, and I give the floor for the next presentations, please. Thank you, Mr. Stanislav. And now the floor is given to Kirill Kostogris, who will start our topical presentation on tightness problem. Please, Mr. Kostogris. Thank you. Good morning, good afternoon, dear colleagues, the audience. I will share my presentation now. Do you see my presentation? Yes. These are the results of testing of the models of gas distribution networks of DSOs on hydrogen plus gas and water mixtures. These tests were performed on 5 test sites. Due to the prospective future goal of transporting both pure hydrogen and the mixtures of hydrogen with natural gas to provide for decarbonization. What are the tasks of this study? First of all, to assess possibilities to achieve tightness of the existing gas distribution systems during transportation of hydrogen and gas and hydrogen mixtures, and also for safe conditions of such transportation by studying the models of gas distribution networks on the test sites of regional gas companies. The second goal is to define the influence of hydrogen concentration in the mixture on the leakage volume. Identification of the best hydrogen concentration to be used for transportation with or without updating of the network. The third goal is to check the possibility for providing the tightness of the existing networks according to the existing safety norms. using available measures and using the available gas fittings and materials. Also, determination of the nodes and element DCOs which are not suitable or not reliable, not sufficiently reliable to transport hydrogen, gas and hydrogen mixtures, and to check for safety of this network. What are the peculiarities, specifics of this test? The experimental models of distribution were mounted with the elements of this gas distribution networks, which were taken from the really existing networks. The study was made on the test sites in real conditions of operation, for the temperature of the environment was from -20 to +40 degrees. Next feature is that on 4 test sites in Kharkiv and Dnipropetrovsk, Volyngas, and Zhytomyr during the study, no liquidation, no repair of leakage was made. It was passive testing. Just observation was made, with exception for the cases when it was becoming dangerous. That is how the work under the condition of existing networks was simulated without the modernization. On the 5th test site, however, Ivano-Frankivsk, the leakages were liquidated by tightening or by replacing the unsuitable elements of the pipelines, and thereafter there was observation for pressure drop. That is how the opportunity of updating or renewing was made. Very important remarks to these studies. Before starting the tests, the gas fitting from cast iron was demounted because it is not in line with modern safety requirements, although the Ukrainian norms allow for using it. And those wells were changed for steel analog wells. And the models have greater number of fittings, joints, and other elements where leakage of gas is possible for the unit of overall length. That is why, under the same conditions, the rail networks should have higher tightness, will have higher tightness compared to the tested, to the experimental models. During the studies, the models of the SOS were under the action of external factors which essentially influenced their tightness. The threaded and coupling joints were leaking, were losing tightness under wind and sun actions, and the leakage were increasing in time. The tightness of these joints was providing to return to the previous level of pressure, to reduce pressure drop. And this aspect should be taken into account for future transportation region and mixtures and of the existing DSO. This slide shows was published half a year ago in the International Gas Forum. Upon the results of first trials, first tests with pure hydrogen, 100% hydrogen. But some media interpreted incorrectly the results of these slides, understood incorrectly, and they draw wrong conclusions on that the existing gas pipelines are absolutely unsuitable to transport hydrogen. But in half a year, a complete set of studies was made and the data were processed, and we have got the following results. This is a general chart, general diagram showing the state of pressure of the test sites where no additional tightness measures were taken. The passive check for tightness of the sites was made. What do we see here? When using 100% hydrogen, there was no tightness provided, sufficient tightness. And it would be a wonder, it would be a surprise if such pipes would provide it for tightness of hydrogen, because significant part of the existing networks was constructed under the Soviet times with the admixture of 50% of hydrogen. Also, the relevant tightness wasn't achieved, but with 20 to 10% of hydrogen in the mixture, in one of the test sites, the pressure drop speed was relevant and compliant to transport the mixture. This norm is made 0.1% per hour. As regards the test site, where the possibility of bringing these gas networks to the necessary relevant tightness was studied by updating, by changing them. These data are shown here on the slide. Even when using 100% of hydrogen, not only the relevant tightness from the point of view of safety was provided, but there was also a big backup reserve. The pressure drop speed was an order lower than required by the norm. So with the measures on replacement and functional, the existing networks was provided, both for hydrogen, pure one, and for hydrogen and natural gas mixtures. So the results of these studies prove to the following. The replacement of low quality or unsuitable for transportation of gas and hydrogen mixture elements of the gas pipelines and good quality of jointness tightness gives an opportunity to achieve pressure drop speed of not higher than 0.016% per hour, which is an order lower than the norm of conditional tightness, 0.1% per hour. And to replace the detected unsuitable elements of gas pipeline and to provide for additional tightness the products of the available assortment, available line of these operators was used. And the relevant condition to change the unsuitable elements was obtained in one test site. The pressure drop speed for hydrogen was higher 2 times compared with the natural gas filling of the gas pipeline. But taking into account that the calorific capacity of hydrogen is 3 times lower than for natural gas, the loss of energy equivalent of gas plus hydrogen fuel with leakages will not higher than the same for natural gas only. And the wells and eventually other cast iron fittings require replacement. Such elements are not reliable for hydrogen mixtures being higher than 10 to 20%. The wells with sliding wells, threaded or coupling joints, and the low quality weld seams, weld joints. Also, such parameters have to be checked additionally. Change of strength, penetration, penetrability, and other properties of the pipelines made from polyethylene during a long influence of hydrogen pressure. Also, those who were used already to change, to improve the strength, penetrability, and other properties of steel pipelines, which under a long-term influence of hydrogen under pressure, and also the places of their joints and other elements, included those which were used. And also influence of hydrogen on the tightening elements, on the sealing elements of the pipelines, influence of hydrogen on the odorants, and the workability of the measuring devices for gas leakage, etc., and also the workability of gas regulating equipment during this work. I believe all this works, all these parameters may be studied during future experiments. Then they to provide high tightness on the was when field and gas and mixtures with different concentrations. Physics of low quality or high tightness. Without changing the detected unsuitable elements, it is possible to provide for a relevant tightness for hydrogen mixture with hydrogen not higher than 20%. The typical leakage places were detected, and notwithstanding that with filling the pipeline with mixture with hydrogen, the leakage is increasing compared to natural gas. The results obtained to the perspectives of further studies. Thank you for your attention. Thank you very much, Kirill. And I ask other speakers, please stay within time because we are late in time. So Boris and the next speaker, please stay within time, within 10 minutes, so we could have time for questions and answers and discussion. And now I would like to give the floor to the professor, Boris Soroka, who will start talking on the hydrogen tests, which already took place on the Zhytomyr test sites and are still to be made on Ivano-Frankivsk test site. Please, you have the floor. Yeah, can you hear me? The topic of my presentation, a very brief presentation, is the energy properties of the fuels containing hydrogen. But I want first to give some information, preliminary information, which was not very much available at all. Firstly, talking about the overall competitivity, we should know that the works connected with inclusion of hydrogen or hydrogen-containing mixtures into the content of the fuels in different areas of economy, of industry, from transportation to other industries. All this is connected to the solution of the problem. All that will serve for decarbonization. And the assumption is that decarbonization, meaning the CO2, etc., emissions which come to the environment, first of all, methane and carbon-containing compound, methane, how CO2 is main pollutant, a massive pollutant of the atmosphere. They assume to be a main, but the assumption is not absolute truth. It might be and should be corrected, adjusted, because the greenhouse effect is connected with the influence of the accumulated properties of combustion products, to which belong both CO2 and water vapor. Uh, and there is much more of water vapor or steam which results from the combustion. So this problem is being studied. But if you take as core assumption that decarbonization is a main mean to save from the greenhouse effect, then we have to use the fuel without hydrogen, which wouldn't contain hydrogen. We should go away from the organic fuels and from most alternative compounds. specifically those bio fuels which are derived from bio products. I already mentioned that this trend connected to the use of hydrogen concerns not only the domestic users and the municipal households. It concerns significantly the industry. We now observe a strong movement of when the potent manufacturers of equipment for metallurgy, meaning the ovens, etc., metallurgy ovens, they are re-equipping or creating new equipment, new metallurgy equipment, which uses hydrogen as a fuel and 100% hydrogen, or maybe some mixtures with hydrogen. First of all, natural gas plus hydrogen or methane plus hydrogen. These trends are parallel to serve for decarbonization, but the solutions are very different, are made in a very different day. When talking about domestic use, domestic fuels, the burners, the burning device, meaning the combustion chambers for these domestic appliances, are designed to use, first of all, atmospheric burning, which are ejection devices, and assume to have a 100% preliminary mixture of the at least with at least primary air oxidizer. In the industry, it is realized quite in a different manner. I will not say how it is made, but anyway, now a project was already realized, was already implemented in China with chemical processes when the hydrogen is present there in the fuel, and the development is close to be completed in Sweden. I will not tell the names of the companies dealing with this project. With 100% of fuel, hydrogen fuel. These were general remarks, and now, so this interest towards hydrogen would be improved by the information what really hydrogen gives. We parallelly conduct basic physical, thermophysical studies and theoretical calculations and experimental tests together with or guided by a regional gas company and the company Naftogazbudinformatika. And now I'm going to the essence. I apologize for this digression, for this information, but I believe it is useful for a broad audience. We do study, first of all, the properties of hydrogen and hydrogen-containing compounds or mixtures, and the number of these properties which we can and which will be ready to consume are more than 20 such properties which allow to judge on hydrogen and hydrogen-containing mixtures as on a good, on a commodity. That is how we regard the fuel. First of all, I want to say about the data. These are the data on the theoretical combustion or burning temperature as main characteristic. The calculations are made from 0% hydrogen, the pure methane, up to 100% of hydrogen in the mixture. And this is that the temperature of combustion burning is increasing. The calculations were performed with different methods, and they confirm the bias makes just 0.5%. This was the first calculation according to the data of Ukrainian missile producing or missile fuel producing data. And this is NASA calculation, and the deviation between the data is less than 0.5%. Next property being studied, it is there's something on the screen, but there's something on the screen which covers the screen, but one should remove it. Only the person who has this obstacle can remove it. Okay, clear. And next property is the thermal capacity or thermal yield of combustion of burning. We have to have present one very important point. The properties are, as a rule, studied under standard conditions. That is 298 degrees Celsius, 273 Kelvin, and the amount, the quantity of the substance is taken under normal conditions, just a normal cubic meter. We see the monotonous, even drop of or decrease of the combustion, the calorific capacity of gas combustion from methane towards hydrogen, also almost 2 to 3 times. Now, it shows calorific capacity of burning and higher, depending upon the content of hydrogen in the mixture, for 1 unit of mass of kilogram, or per, as I already mentioned, per 1 cubic meters. Now, very important property for gas people, for gas experts, which takes into account heat transfer under a fixed pressure, is Weber number. And we have higher and lower Weber numbers per 1 cubic meters. We see that this parameter is passing through an extreme value. Weber number, I believe everybody knows it, includes the factor, the co-multiplier connected with specific density S in relation to R. This table shows combined accumulated main properties of this mixture fuel from 0% of hydrogen through all possible to 100% of hydrogen, including higher and lower calorific capacities of combustion, and higher and lower Weber numbers. But we have to have present that the quantity in cubic meters is taken under standard condition. The same data are for cubic meters under normal conditions. I want to underline once more that properties in normal, no, it is connected to number. It is not discussed indicated that is calorific value resulted are too low because the volume and equipment taken advantage uh, is a point for serious and strong in the calculations. Next important parameter which allows to judge on the fire and explosion danger of the properties of the fuel is the laminar burning velocity. And this burning velocity is taken and is considered for stoichiometric mixture, and also this function at maximum speed of dissemination or propagation depends on the redundancy, on the excess of air. And for the hydrogen, the maximum depends to the excess 0.6. It is not usual because mainly for other fuels, this ratio is close to another value. And these circumstances allowed us, this graph shows the dependency, the ratio of maximum velocity from the contents of hydrogen and the coefficient for excess air factor corresponding to this maximum laminar burning velocity.
Относительно безопасную концентрацию. Хотя использование таких смесей там вносит
would require some changes to the system of combustion of the burning. It will change the influence on the work on the operation of the device, the burner. Now talking about energy characteristics of domestic gas appliances, depending upon concentration of hydrogen in the mixture and the consumption of hydrogen. This is two parameters we see at the work of the equipment. For natural gas, this graph shows depending upon fuel consumption per gas cooker Nord of the type Nord in this case. You can see that the dependence, the efficiency ratio, which is described by the norms, the Ukrainian, these two, the Russian, Chinese standards, it is an extreme dependence, but optimum for every separate gas appliance for the gas cooker, is certain consumption of fuel with efficiency ratio. You see this for a burner. The top area highlighted in blue is 50% and higher. This is the efficiency ratio. This is their extreme characteristic, and it is achievable for this concrete gas cooker. And now, upon the results of our tests, this is the characteristic of Greta gas cooker burner. Goes about different fuels. Here, this characteristic once again is extreme one, but you can see that the hydrogen share, hydrogen fraction allows hardly to provide for the relevant compliant for the relevant concentration compliant to the standard and the relevant efficiency ratio 59%. But the last one, last time during the last test, we have got the parameter for Greta. This is for Greta, and just recently we conducted 5 tests of Tula 2 gas cooker. You can see that the standard value is not provided, is not achieved. Such cookers don't provide to comply with the requirements of the standards, but the dependence of the efficiency ratio from hydrogen share is extreme one here as well. What is important to say? The burning of hydrogen allows to reduce the emissions of main toxic substances. Just to tell a couple, because combustion products contain significant percentage of H2O. You can see it for different types of mixtures from 0 hydrogen to 100% hydrogen. It shows how much of different components are here and what are the emissions of NOx and CO. You can see that even in the case of natural gas, when there is a steam, water steam as combustion product, the concentration times, but where from can we take the steam? But in case of burning in domestic appliances, the hydrogen containing components, it shows here up for 50% and for 100%. The contents of hydrogen is such that in the products of combustion, there are the big contents of water, steam, which is participating in the process of combustion and is inhibiting, is suppressing the formation of nitrogen oxide. These data have been received by us in Zhytomyr test site. And it is very interesting characteristic here for combustion of fuels with different hydrogen contents on the emission of CO and NO and nitrogen oxide. You should have present that combustion of hydrogen without water vapor. This is the last slide. Basically, when burning hydrogen, there is more NO than when burning the natural gas. And here, thanks to that, in the products of combustion of gas domestic appliance, the atmospheric burners contain steam, water steam, water there in the content of nitrogen oxides is reduced. That is all from my side. It is a complicated problem from the point of basic fundamental processes of combustion, which we should consider. In the practical applications, we have to take into account different aspects, not only environmental ones, because we encountered two circumstances which are special ones, specific, when burning hydrogen-containing fuels. So we have to remember about that and take it into account. Because the two pilot projects which are realized in United Kingdom and in Germany are limited by the concentration of hydrogen up to 20-23% only. And at these limitations I wanted to talk about are minimal. It goes about condensation of water vapor in combustion products. It is very important for low temperature consumers like domestic boilers or burners. And the second point, the creation of counterflow, the element of detonation origin. I have a very small video for 30 seconds to illustrate this process, how this process of is emerging in the gas cooker. At the use of 50% hydrogen mixture, what happens there? What is interesting here? When those phenomena I was mentioning about this gap, this jump, they appear at non-stationary transitional process. You see this jump, this disappearance of gas of burning, and after that, there is a detonation which brings the fire once more to appear, and it is reignited. The flow is reignited. I'm sorry for overtaking the time. I wanted to deliver as much information as possible. I believe it will be very useful for the wide audience. Thank you. And now the floor is given to Mr. Pianik. Please also stay within time because we have, please stay within at least 10 minutes. No problem. Thank you. Dear colleagues, good morning and good afternoon. A very practical presentation. The image, the photograph of domestic boilers work using methane and hydrogen mixtures. The task is to use both modern and old type domestic boilers, both with hydrogen. No, this is a photo of a torch of combustion of a pure natural gas. The photo to the right is 50-50 hydrogen and methane, 50% methane. There is no substantial difference in the pattern of that torch. The tests were performed on the test site in Chernyhivsky site of Zhytomyr. You see all the test equipment. Two boilers were tested. Roda microduo CS24 and domestic boiler Zhytomyr. They are very different, substantially different, because on Roda boiler there is an enforced evacuation of combustion products by a ventilator, which removes combustion products in the air and aspirates additional air to burn the gas. In Zhytomyr 3, the standard domestic, there is a standard flue tube, and there is only mattering of temperature difference, what appears in that flue pipe. What are the expected results? When we work with the mixture 50-50 hydrogen methane, we can see that the volume of gas with the same pressure which passes through the burner is increasing. You can see it for both boilers. The upper graphs, the green line shows 50-50 a mixture hydrogen methane, and the lower blue is pure methane. You can see it well. Talking about the capacity, of the boiler, obviously it drops. The higher capacity is achieved when it works with pure methane, and the lowest capacity is when there is a mixture of hydrogen and natural gas. It is obvious. Let us review some less obvious issues. For efficiency ratio of the boiler for RODA, when it worked on pure methane, it has got highest efficiency ratio indicators. For Zhytomyr 3, vice versa. The highest efficiency ratio was when it worked on the mixture of natural gas and methane. We evaluated, we assessed, and detected why it is happens. What is the main driver, main reason of the situation? We looked at the mixture, and the logic is quite similar. But when talking about the temperature of combustion gases or smoke gases, you see in RODA it is up to 20. In the geometry is up from 0 to 20 with the same load. The influence of air on the amount of gas is much lower, so less calorific energy is leaking and less combustion products are remaining. RODA is equipped with reinforcement ventilation. And due to increase of combustion products temperature, the reduction of removal of combustion products is happening. So it responds better to higher temperature. It is closer to stoichiometry here. In this situation, when we give more gas, it passes through it less air, then it means expenses with loss of combustion products, emission of combustion products is reduced. The lower graph shows the pure natural gas, and the upper green line is hydrogen mixture. Due to that, the temperature in natural gas is higher, we get low, and the lower is volume, we get lower expenses, lower consumption with combustion products. And what is the most interesting, what Boris Semenovich, the previous speakers mentioned about, what is the difference between RODA and Zhytomyr? With RODA boiler, when using the mixture of hydrogen and natural gas, there was condensation appearing, but it wasn't going outside the limits of the boiler. We had problems on the exit of exhaust pipe, of fume pipe. The sensor showed condensation, but that condensation didn't remain in the boiler. But in Zhytomyr 3, there was a potent flow. 300 grams of condensate were forming in 1 hour. That is, it is very interesting from the point of view of energy, but from the point of view of equipment, it is very unpleasant. Working without exhaust pipe, without fuel pipe, this water goes outside the equipment. If the boiler has a fume pipe, all this humidity, all this water will remain inside the pipe, meaning inside the boiler, and it will make problems. The equipment will be rusted and will be deteriorated. So when talking about using boilers of old design, which foresee for the use of fume pipe, exhaust pipe. You see the lower graph. This is a natural gas use with it, and this is a coincidence of 20 and 10%. This is a situation when we working with old design boilers. We shouldn't go higher than 20% of hydrogen in mixture. Now a couple of words about ecology. Here everything is clear. This is a standard graph for CO, and this is for both boilers. When we have a lot of air or little of air, it is bad, and CO is increasing both with high or low volume of air. So there should be some optimum inflow of air. Obviously, as well, when there is higher amount of hydrogen, the quality, the efficiency of burning is better. More complicated is the situation with nitrogen oxide, but you see there is no substantial difference between the two type of boilers. What is important to say, the use of the mixture of natural gas and hydrogen with standard boilers with no adjustment, no setups. The user even will not will not see the difference of 10 to 20% of hydrogen addition to the natural gas. The only substantial difference will be made by the calorific capacity, thermal capacity of this gas, which will be reduced. And when paying not for 1 cubic meters, but paying for 1 kilowatt hour, it is an obligatory condition when working with mixtures of hydrogen and natural gas. That's all from my side. Thank you for your attention. Thank you. So we exhausted the topics of presentations, and we have a video on preparation of Ivano-Frankivsk test site to fire tests. Please, I ask to launch this video now. We are now found on the test site of the regional gas company in Bogorodchany city. It's in Ivano-Frankivsk Oblast. Soon, the next step of fire tests, we call them fire tests of hydrogen. Why we call it them here? Because we shall burn here different concentration of gas and hydrogen mixture in real conditions, which are as much as possible close to the real life. In this test site, we successfully completed the relevant tests of different concentration mixtures, including pure hydrogen. These tests we were conducting together with the Ukrainian Gas Institute of the National Academy of Science and together with our Ivano-Frankivsk Institute of Oil and Gas. As regards the second step of this, the specifics of this test site consist in that here we have concentrated practically all the elements of gas distribution network which are used, which operate in Ivano-Frankivsk Oblast and also in most of Ukraine, and which are operated in the existing gas pipelines. In our, this is our improvised kitchen where we collected most of gas consuming elements like gas cooker, boiler, so on. All these consuming elements are used by Ukrainian consumers. These are real examples. That is where in the future the hydrogen mixture will be consumed, will be burned. So we have to study the different modes of combustion. Our model of gas distribution system has a group of bottles with gas and hydrogen, natural gas and hydrogen mixtures. From here, this mixture will come to the model of gas distribution system and to our improvised kitchen to be consumed by gas appliances. Here, the pressure of gas is reduced to an medium pressure and is supplied through the pipeline to the relevant distribution nodes of different manufacturers and different types and sizes, so to study their meteorological characteristics. Accordingly, the low pressure gas will be supplied to the improvised kitchen for fire tests to see how the gas mixture is burned in these appliances. The gas appliances installed here in this kitchen will be tested for burning different concentration gas and hydrogen mixtures. And the appliances are those most popular and most used by different groups of consumers. This is an heating convector, a gas cooker, a water heating boiler with the same principle of work. This equipment is new one and was selected upon the study of assortment of the mostly used assortment for Ukrainian consumers. During the study of hydrogen concentration study will start from the fraction of 5%, then 10, 20% of hydrogen mixture, and will finish with higher concentration. Thanks to this, the specialists will study the parameters of efficiency of gas appliances, so we could understand how efficiently the equipment on gas and hydrogen mixtures works, and also to study the evacuation of combustion products to see what are the emissions into the atmosphere. The tests will continue for 1 month, and at the end, the conclusion will be drawn on the parameters of work of this equipment. This room is equipped with additional safety measures. We have signalization alarm system for natural gas, for hydrogen, and for CO2 gas. It works continuously and it allows to detect the micro concentrations of gas in the controlled premise. During this test, meteorological characteristics of our gas meters will be studied, which are placed here to see how the hydrogen influences them. Dear colleagues, we exhausted our agenda for today's webinar. Now I want to give the floor to Stanislav Kazda. And after that, we shall wrap up. I want to tell you at once that send your proposals to our email. Also, your proposals, your suggestions, how we could make these webinars more interesting, more visible. So not just to see the results of scientific, but also that we could discuss, we could talk about the perspectives of use different technologies and also the perspectives of using the gas distribution system for future distribution of natural gas and hydrogen mixtures. And now, Mr. Stanislav, please, you give the floor. Let me at the end say a couple of words. I hope that you have seen that our experiments have been conducted with the study of rather deep scientific and technical problems, because we understand as much as possible of problems and difficulties which could be encountered in the future use of our these distribution networks. As I already mentioned, we are ready to exchange information to communicate with all those who are interested about the topic. Everybody who will be interested to get information from us about our experiments and who is ready to share their results of experiments, please contact us. I thank all the attendants of today's webinar, all the speakers, and I will be waiting for you in the next webinar in 2 or 3 weeks. Thank you very much. Dear colleagues, I thank everybody who attended, who participated in our webinar, and I hope that in the next meeting, we shall be able to have more bright, more visual picture and more interesting way to deliver to you the results of scientific and technical experiments. Thank you for the information and meet you in next times.